Bismillah ar-Rahman ar-Rahim. I'm Bushra Al-Muhammad. I'll continue talking about impression materials with the same reference pages from Richard Minort from 137 to 152. We'll be talking about elastomeric impression materials, polysulfide, silicons, and polyethers. The impression materials that we discussed so far and previously are not good enough for taking accurate impressions for dentate patients. The alginates are weak materials that provide poor reproduction of the surface detail. Agar is dimensionally unstable and only suitable if the laboratory facilities are close to hand. And rigid impression cannot be removed from deep undercut. That's why there is still need for impression material that are accurate, show large recoverable deformation, and has adequate long-term dimensional stability. And these were found in elastomers. They are mainly polymers that are used at a temperature above their glass transition temperature. And this process of binding the chain together to form a three-dimensional network is known as cross-linking. There are three main groups: polysulfide, polyethers, and silicon. The polysulfides are polymers with mercaptan groups that oxidize by an accelerator for cross-linking. And this reaction causes a rapid increase in the molecular weight of the polymer, which causes the paste to be converted into a rubber. This reaction is exothermic, and the water is a byproduct of the reaction. Polysulfides are presented as a base paste that contain polysulfide and fillers such as titanium dioxide, and we have catalyst, which will cause oxidation of the mercaptan group that will result in chain growth and cross-linking. The most commonly used is lead dioxide that gives a brown color. So the lead dioxide will oxidize mercaptan group, and this will give us polysulfide plus the byproduct, which is water. As you see from this picture, we have two pastes. One is the base and the other one is the catalyst. When mixed together, we get the polysulfide. The handling characteristics of elastomers. First, the polysulfide. The setting is susceptible to temperature and humidity. The working time is 6 minutes and the setting time is 13 minutes. They are both accelerated by heat and moisture. The permanent deformation is higher than hydrocolloid. The flexibility decreases when the consistency is higher. The tear strength is 8 times higher than alginate. It is an excellent for detail reproduction. The disadvantages of polysulfide is the poor color and offensive smell because of the sulfur, the staining because of the lead, and exhausting mixing, long setting time, shrinkage on setting, relatively high permanent deformation. An interesting feature about polyethers is that they were developed specifically with the dental profession in mind. And it is presented as a base that has polyether and catalyst that contain aromatic sulfonate ester. There is no byproduct that is associated with this reaction, and it has good dimensional stability. Properties of polyether impression materials. The working time is 2 minutes, which is the shortest. Setting time 3 to 5 minutes. The flow is high when the shear stress is high. It's a thixotropic material. Permanent deformation is less than the polysulfide but more than the addition silicon. Modulus of elasticity is much higher than other impression material except for addition silicon. It absorbs water in storage and must therefore be kept in a dry environment. Polymer should never be placed in the same bag as an alginate impression. Moving to silicons, we have condensation cured silicons and addition cured silicons. Condensation cured silicons are presented as a base paste, polydimethylsiloxane polymer with hydroxyl terminal groups. The activator paste, which will cause the cross-linking, it is achieved by tetraethyl silicate. The byproduct is alcohol. The released alcohol from the condensation cured silicon compromise the storage stability. It is really important to control the amount of activator paste used. Insufficient tetraethyl silicate will give rise to an incomplete cure, which will leave the material with poor mechanical characteristics, such as high permanent set. Also, excess tetraethyl silicate will leave the material with many unreacted ethyl end groups. From here you can see the setting reaction of the condensation cured silicons. You have the linear polymer and the cross-linking that is achieved by the tetraethyl silicate. The alcohol that is released from this reaction contribute to the contraction and shrinkage of this impression. The polymerization shrinkage is more than the polysulfide, 0.5%, and it is less when the filler content is higher, and it occurs mostly in the first hour. The permanent deformation is less than the polysulfide because it has higher cross-linking. Condensation cured silicons suffer from erratic setting behavior, and one of the reasons is that tetraethyl silicate is susceptible to hydrolysis, so when it's contaminated with moisture, it becomes inactive. Addition silicons, which is known as polyvinyl siloxane, is presented as a base paste of polydimethylsiloxane polymer with vinyl terminal groups and a reactor paste of platinum catalyst, and this reaction has no byproduct. Properties of addition silicons: it has superior dimensional accuracy, the working time is 5 to 8 minutes, flexibility is lower than all other materials except polyether, tear strength is moderate, dimensional changes in first 24 hours, 0.1%, permanent deformation on removal, 0.2%, which is the lowest of all impression materials. The percentage of flow is lowest of all impression materials. Hydrophobic, some types have surfactant added to the paste, and the putty displaces wash. Wearing latex gloves will inhibit the setting of addition cured silicon putties. Putties should not be mixed when latex rubber gloves are worn. Wash hands thoroughly prior to hand mixing. Components in the rubber, not the powder, will retard setting by poisoning the platinum catalyst. The mixing of addition cured silicon putties is easier with the gun delivery system. It will avoid both the potential for incomplete mixing and the introduction of air bubbles. Moving to mechanical properties, we will discuss first the stiffness. And the stiffness of the impression material once it sets, it's a major consideration of how easy the material will be removed from the undercut. Polysulfide impression materials are the most flexible, then condensation cured silicons, then addition cured silicons, and finally polyethers. The permanent set, ideally when the impression is removed from the undercut, the deformation that will result should be totally and immediately recoverable. The impression material can be ranked as follows: polysulfide, polyethers, condensation cured silicon, and addition cured silicon. With the polysulfide most prone to permanent deformation and the addition cured silicone are the least prone. Tear strength. A high tear strength may give rise to difficulties in removing the impression that has flowed into the interdental spaces. Polysulfide have the highest tear strength, followed a long way down by the polyethers, and finally silicones. Reproduction of surface detail. The lower the viscosity, the better the reproduction. Air bubbles are a problem because details will be lost. Incomplete setting due to improper mixing will result in a non-homogeneous mix. The ability of an impression material to wet a surface can be determined from contact angle measurements. From this point of view, polyethers are the easiest, since it has 49.3-degree angle. This picture shows the material with different consistency in order to explain wettability. When the angle is less, such as polyether, it will cover more surface area. Disinfection procedure. Impressions should be rinsed in water immediately on removal from the patient's mouth, and this is to remove obvious sign of saliva, blood, and debris. Disinfection should be carried out before the model is cast or sent to an outside laboratory. Disinfection of polysulfide condensation and addition cured silicone impression materials is done by immersing them in glutaraldehyde-based disinfectant for 30 minutes. Chlorine compound spray disinfectant is used for irreversible hydrocolloid and polyether impression materials. This table summarizes some of the properties that we've mentioned.